Here is a question I've been asked to do, and inequalities will come up in your exam. Okay, it was the last topic here. There won't be weirdo like A and B inequalities. Like I think we'll deal with that after the exam. But these will be in there, and I'd expect this is kind of about as hard. Like this is sort of 8, 9 out of 10 for the difficulty of an inequalities question you get. So it's up there. Okay. How would you do it? Now I asked a few of you as you were coming in. How you would do it. There's at least 4 ways to do this. Okay, at least. I'm going to show you 3 of them. Okay. And I'll let you decide which way you think is the way I prefer and which way you would prefer. All the methods I'm going to show you, they're all fine. They're all equally legit. Okay. Even if you, like I said before, though, even if you settle on one method, you're like, I love this method. It's my child. Don't touch it. You still need to be able to know how to do the other ones. Right? Because some questions will lean one way versus another. Okay? So,
will they ask you solve this in the so-and-so method?
With a question like this, it'll tend not to be because those kinds of methods, the method I'm going to show you, they're not like well-defined methods, like say the K method, or use the cosine rule, or whatever, right? They're all they overlap with each other, right? They're not very well defined. What you may find is, for instance, if part A was graph y equals blah blah blah, and then part B is hence solve that. That's about as close as I would get. Okay, but otherwise you're free to choose whatever way you like. Right? So let's do method number 1, and you can call it a couple of things. I'm going to call it by regions. Okay, but not just by regions. There's a couple of different ways you can break up the regions. So the first way I'm going to do the regions is with no algebraic manipulation. Okay, so I'm going to take this guy and I'm not going to muck around with it in any dramatic way. So I'm going to take that and run with it. Okay. Now, when you think about regions, okay, all of the work in working out a question by this way is not in the algebra. It's in working out what regions you should have. Okay. Now, one of the reasons why I assume this question was asked is because it's tricky. Yes.
Are we graphing?
I will graph, but I'm not going to graph it yet. Because I know lots of you are graphing averse, okay? And so I'm going to show you how to do it other ways. Okay? Right, now, remember I said the question is, what regions do I need to break it up into? Okay? Now the first thing you notice is, you've got an absolute value. Right? So that means you automatically got 2 regions, right? For absolute value of 3x minus 1, what that's equal to is 2 things. It's equal to 3x minus 1 without the absolute value. It's just regular 3x minus 1. For what region? When does it equal that? X is greater than a third, right? More generally speaking, it's when whatever's inside your absolute value is positive. Okay? And what the value that gives you that is x is greater than a third. Okay? So if x is not greater than a third, if it's less than a third, you have to slap a minus sign on the front. Okay, so you'll get this. Or you could just switch the order, 1 minus 3x. Okay? So I have 2 regions, or 2 cases, if you like. Okay? But if I'm not altering the algebra of this dramatically, okay, I actually have to take into account not just the absolute value, but this denominator. Okay? It actually makes things a little more complex. Why?
There will now be 4 regions. No, sorry, 3.
Well, yes. So think about this, right? The reason why I'm thinking about the denominator is because if I have to do anything with this, I have to multiply through by x, right? But as you know, because x is unknown, right? Could be positive, could be negative. I need to say the negative case and the positive case because different things happen to the direction of the inequality in each case. Okay. So not just is a third kind of like a dividing point. 0 is also a dividing point, right? Because when x is less than 0, when I multiply through, the inequality will change direction. And when x is greater than 0, it will not change direction. Okay? So I have 3 regions, 3 cases, right? So I've got case or region 1, which is x is less than 0. Okay? Then I've got a middle case. Actually, I'll put it parallel here. Which is, it's greater than 0, but it's less than a third. So it's in between that little boundary, okay? And then I've got my final case where x is greater than a third. So obviously it's positive, so I can know what's going to happen with the inequality. All right, so let's go about each case one by one. When x is less than 0, what's going to happen to the absolute value? Okay, which of these cases is it? If x is less than 0, which case is it?
X is less than 1.
It's this one. If x is less than 0, it must obviously be also less than a third. Okay, so that means I'm going to take the minus case when I get rid of the absolute values. So on the top, I'm going to have this 3x minus 1 all divided by x less than 2. Okay, I'm going to leave that. I'm going to come back to it shortly. Okay. Case 2. Between 0 and a third, it's still less than a third. Right? So I still have this case, right? So far, these look the same. Okay. But when you come over to this one, things are different, right? Because now that I've passed this boundary, x is greater than a third, I don't need this minus sign on the top when I get rid of the absolute value. I'm just going to have 3x minus 1 all over x is less than 2. Okay? So now I've set up my three cases. Does anyone have any questions so far? Yeah.
Shouldn't you have a minus sign in front of the x for the first case on the denominator?
Yeah. Why?
Because x is less than 0.
Okay, now, the fact that x is negative is going to factor in when I'm multiplying through by x. It'll change the direction of my inequality, but it doesn't add me another minus sign here, because then I'm back onto this case, which is quite different, right? This is x negative, this one's x is positive, okay? So, just the one negative, just the one negative. Okay, I only really add in the negative because of the absolute value on the top. There's no absolute value on the bottom.
Right, yeah, right.
Okay. All right, now, for reasons that I hope will become clear in a second, right, I'm going to start with case 3. I think it's actually the simplest, right? Now, x is positive, so when I multiply through by x and have 2x on the right-hand side, what happens to the inequality? Nothing, because x is positive, right? So 3x minus 1 is still less than 2x. Okay, now let's just rearrange. 2x over here leaves me 1x there, and a 1 moves over, so less than 1. Okay, now what does this mean? You have to put together the case with your conclusion. Okay? So this means which part of x is greater than a third satisfies my inequality? Which part of it? Okay? And the answer is the part of x is greater than a third, which is also less than 1. Okay? So you got a number line, you've got a third, and you've got 1, right? So I'm just interested in this part to the right. And this is telling me, well, that part to the right, the one that you really want, is this part in between. Okay? So from case 3, here's my conclusion. I'm between a third and 1. Okay? Right, let's go ahead with this one. Now, just like in case 3, x is positive. Okay? So when I multiply across, the direction of the inequality does not change. Right? So I've got this. So far, so good. Now I might as well actually, on this line, expand that. So I'm going to have that. Okay. All right, now let's see, where shall I put this? I guess I'll take the 2x over, and I'll also take the 1 over, and then I can divide by minus 5. Is that okay? Does it all check out? That looks all right. Now again, I have to combine my case with my conclusion. Here's my case. So I'm only interested in this area between 0 and a third. Okay, that's what this case means. Just forget about the rest of it. Which part of this part works? Answer, the part that's greater than a fifth. Right? So that's, I don't know, somewhere like there. Okay, so greater than a fifth. So now I've got this little region in here, which works. Okay, so from case 2, what I've got is this. I'm between a fifth and a third. Is that okay? Right, let's finish up. Last case, first case, okay, because I think it's the most confusing. Because x is negative here, right, when I multiply across, the inequality flips around. Okay, so I'm going to have, let's expand this, so minus 3x plus 1. When this x comes over, the inequality changes. Is that all right? Yeah? Okay, let's take the 2, let's swap the 2x and the 1 over. I keep doing the same thing, right? I've got minus 5x, and then I'm going to have minus 1. Then I divide by minus 5. This looks familiar, doesn't it? Okay, now hold on a second. What does that mean? Okay, because x is less than a fifth.
It's just x is less than 0.
Ah, yeah, okay, so remember, the way that I combine my case and my conclusion is I think, all right, when I look at this case and solve this algebra, all I'm thinking about is the region to the left of 0. That's all I'm thinking about. And when I answer this, it'll tell me, okay, which part of this line, of this section, works? Okay, and the answer is all the parts of this section that are less than a fifth. Now, how many parts of it are less than a fifth? Answer all of them, right? So even though this is more restrictive, sort of more restrictive, depending on your perspective, okay, than this, what I really take is this, okay? So my conclusion from case 1 is x is less than 0.